Hello, and thank you for joining me today. I am Hamida Rebai, and today I will present a session about the best practices to prepare .NET Docker images. We will have some demo to do that. And who I am? I am Hamida Rebai. I am Microsoft MVP in Developer Technology, a solution architect, a member and speaker in .NET Foundation. I'm also MCT Azure certified and book author. If you have any questions during the session, you can add it in the chat, in the comment, in the chat comment, or you can follow me on my blog. You can reach me by email or LinkedIn. So today we will talk about the container, the Docker, what is the difference between them. We will have an overview about container image, and after we will need to understand what is Docker file before going to create our Docker file and optimize this Docker file. So, containerization is an approach to software development in which an application or service, its dependency, and its configuration are packaged together as a container image. The containerized application can be tested as a unit and deployed as a container image instance to the host operating system. Our operating system can be Linux or Windows. Just as shipping containers allow goods to be transported by ship, train, or truck regardless of the cargo inside, software containers act as a standard unit of software deployment that can contain different code and dependency. And here we can see in the picture we have two application for first application, the second application, and two services. So Docker host is a container host that where we can add multiple application, multiple services, containerized application and services. We have multiple benefits of using containers, and one of the best benefit is scalability because you can scale out quickly by creating new containers for short-term tasks. And for an application point of view, instantiating an image means creating a container. In our case, we will see the difference between image and the container after. Is similar to instantiating a process like a service or web application. We have another benefits like reliability, but for reliability, however, when you run multiple instances of the same image across multiple host server, you typically want each container, in our case it's the image instance, to run in different host server or virtual machine in different fault domains. In short, containers offer the benefits, multiple benefits of isolation, portability, we have agility, scalability, and control across the whole application lifecycle workflow. The most important benefit is the environment's isolation provided between the dev and ops. Here we talk about the DevOps. Now we need to understand the difference between container or Docker container and image. A Docker container is a virtualized runtime environment used in application development. We mentioned that before when we talked about Docker, the definition of Docker. We are able to create, run, and deploy applications that are isolated from the underlying hardware. So, a Docker container can use just one machine, share its kernel, and virtualize the operating system to run more isolated processes. So, Docker containers are lightweight. But for Docker image is like snapshot in other types of virtual machine. It is a record of a Docker container at a specific point in time. Docker images are also immutable. While they can't be changed, they can be duplicated, shared, or deleted. The feature is useful for testing new software or configurations because whatever happens, the image remains unchanged. Containers require the existing runnable images to exist. They are dependent on images because they are used to construct runtime environments and are needed to run your application. And we can see here how we create our container from the image. We do that using by configuring a Docker file. So each Docker file is a script composed of various commands, it's like instructions, and arguments listed successively to automatically perform actions on a base image in order to create or form a new one. They are used for organizing things and greatly help with deployments by simplifying the process startup to finish. Docker files begin with a definition uh, by defining an image we use from which the build process starts, and after we have a different method command arguments, so it's followed by different things instruction, we call it here instruction or commands, and in return provide a new image which is to be used for creating Docker containers. So to understand that, we start by an existing image. We find all the images in Docker Hub, in the website of Docker Hub. We select an image, for example, for .NET, for any other provider. After we create our image, and from this image we are creating our container, and we use Dockerfile. We start by the, let's say, a basic Docker file. What it can include. Let's start by the first one. For example, here we said before that we start by from. For content, the first thing we need to define is an image we want to base it on. In our case, we will work on application, .NET application. In our case, we use .NET 7. We can use .NET 8 if it will be released, but currently in our sample we use just the .NET 7. We also need to set a working directory where we want the files to end up on the container. We do that with this command line from and work dir. We grab an image with a small operating system image made for .NET Core in our case. Next, we need to copy the project file ending in .csproj. Additionally, we also need to call .NET Restore to ensure we install all specific dependency. And next, we need to copy our app files and build our app. And after, we can specify our image and our working directory. And there is a difference through this time we want to copy our build files to app publish in this case, for example, here in the end. And finally, we add a command for how to start up our application. We do that with the command entry point, as you can see here. And entry point takes an array that transform into command line invocation with arguments. Our command looks like, and simply means that it looks like here we use .net and the name of application .dll, and means that it will invoke .NET in our case with our application on the command line. Now to create an image, we can use the command line here, the Docker build with multiple parameters here or multiple arguments. So for our case, we use Docker build -t means that I would like to give to our image a name. In our case, your solution image, for example, we use multiple name, becomes the image name. Our last argument is dot here, punctuation dot. It means that we can find the Docker file. Always the Docker file is in the same directory of the solution, the entire solution, which our case the current directory here. Always we use that. And we have an image. It contains our application code. We have multiple commands utilities, as you can see here. Now we see how we can run container. We will use this command line after when we create our application. We add with Dockerfile. We show you how you can add it automatically after we try to start from a basic Docker file. So here in our, if you would like, here we build our image. We will see that. We see that in Docker Desktop. We will see that how we can have an image after we run our solution. And we use Docker run. Minus D simply means that we run the container in the background. Minus P in this case means that we will match an external port to an internal container port. For some Dockerfile specification, you need to explicitly expose an internal port. This is not needed in if you will use port 80, for example, but it's necessary to add that here, the port, to be able to run your solution after. And minus minus two minus, here we have two minus name, means that this giving us the name. We will give a name to our container. We here it's about the name of our image. Here we need, okay, to give a name in our container. We check that in Docker Desktop, where we can find our containers created from this specific image, because here we will mention what is our image. And before that, we have this flag here, minus minus rm, means that Docker will remove the anonymous volumes associated with the container when the container is removed. So we'll use this parameter after to run our container in our sample. And as you can see here, we have some optimization that we will use it after we talk about it here, to use in our Docker file, in the publishing, in the command line of publishing. We see that after in details. What we need in for our demo, because we started demo, it's more simple. We need to install Docker Desktop. It's similar like this one. Here we have Docker Desktop already installed. You can go to Docker and you create an account. It's free, and after you can download Docker Desktop. It can be a download for Windows, for Linux, for macOS. So it depends from your operating system that you are using. So here we will find our images that we will build. We start by building in the different images, and after we run from image container and we see our container here according to the name. And what we need also, we need Visual Studio. You can use Visual Studio Code. Today we will use Visual Studio Code, but you are able to use Visual Studio 2022, 2019. So it depends from the tool that you'd like to use, but we can do the same thing. The difference between Visual Studio Code and Visual Studio 2022, that we in Visual Studio Code we will use the command line. Maybe in the Visual Studio 2022 you just a few click to run. But today we show you our demonstration will be on Visual Studio Code. And for Visual Studio Code, we need to add Microsoft C# extension, Docker extension also. As soon as your environment is ready, we will start the different demo. So we start by creating and building Docker image. We will use a basic Dockerfile. We show you how we can add in Visual Studio Code. We add the basic Dockerfile that we already presented before. And after, we will try to see how we can add tags, different tags. It's best practice to use the tags. And in the end, we will try to show how we can optimize your Dockerfile. Let's start by the first one, is building a Docker image. I will open Visual Studio Code here, and here is empty one, and I will try to create a new application using .NET CLI, .NET new MVC. It will be MVC application in our case. So, and here, if you'd like to create a new Docker file, it's simple. Control Shift P, and here we select Docker, add Docker file to workspace. As we said before, we need to install the extension of Docker before, and we click here. We select here for your platform, application platform. After, we can select your operating system. You can select here, for example, the port 8080, for example. We will not use this Dockerfile because we'll try to see how we can optimize. This is an optimized Dockerfile generated by Visual Studio for you. And here, as you can see, activating C# extension. So it takes a few times to get this one. And even your Docker file is created, we see that the Docker file will be created and another file that will be added also. I don't know, it takes a few time here. So else you can, because we need, it takes time. I don't know what happens to Visual Studio, but if you don't want to generate automatically, sorry for that. If you don't want to generate automatically your Docker file, you can just click here, new file, and you add Docker file. It's simple here. And to start, we just wait. But to start, we can start with this one. So to be faster, because we don't have a lot of time. So my basic the Docker file that we already presented before, this one. So we have the build stage. It's we have here two stages. The first one is the build stage that will, and we have another one that is runtime stage. As you can see, we have the SDK and we have the ASP.NET 7, .NET 7. So in the first one, we have an image that is based on the SDK, and we have the CS proj files that are copied to the directory, and the .NET command restore. We use this one, restore. After we copy everything to be able to build them, we have here .NET publish, and in the runtime images, we will use the ASP.NET base image, which includes the .NET Runtime, and the working directory will be set in src, and we copy after here the different elements here from the build to the output of your solution. So that will be published after. We use expose 80 because we'd like just to display our application uh, uh, using the port 80. It's more simple. You can use another port, so it depends of you. And here we have the entry point command, specify the command to be run when the container starts, which is in our case to execute. We will use .NET command line to execute our DLL, the solution. This is the name of solution .dll command line. So I know what happens here. Maybe I need to close it, but it seems that is not working here. So even you save, we can use the build. I try to see if I'm able to, but I think it's blocked. I will close and open again maybe. Visual Studio. Don't know what happens. So this is the basic Docker file that we are able to use it. I hope everything is working here. Maybe some updates. Sorry for that, for some convenience. Okay, okay, no problem. Here our try to create our builds. Okay. So here we'll use .NET build. If you remember that we can use Docker build, Docker build, sorry, Docker build -t. I will give a name to my image. I don't know if it's clear for you. Example, in our case, I will give here a number that is the tag in our case. So we say 1.0, for example, and we have the current directory where our Docker file exists. So we have dot, and after we click enter, we see if it builds. It's okay here. So it takes few seconds to build. After this image will be added in the list of images here, and we will try to use Docker run. After we use Docker run to be able to run our application to create our container from this image. As you can see here, the build is finished. Here I have my Docker sample. It's using latest stack. We try to make some changes here. And here we have Docker. And as you can see here, we don't have the container already. We will use, I will try to create another, maybe another one. I will try this to make this one. So this is Docker run. I don't know if you are able to see that, but Docker run minus p, and here we use the port 80. We give a name, minus name, to give a name to my container, and here we need to say what is here one, what is your image. The image will be latest in our case. Try if I can find it here, and it takes few seconds to run. It's really, here we can see our container. If we go back to image, we see that it's in use. If we click in use, we have this image, and here our application will be running. It will run in our case. And this is my application, just MVC, simple application. So this is the first thing to do. Now we'll try to see how we can add tags. You are able to add tags using command line. I will try just to make sure here, this one. We can use the tag, for example, in our case, we will use the build. Here in our case, we say I Docker simple. We given a number 1.0 here. It's in this way, and you are able to create a new tag. This is an example. I will show you that here in images. We find another image. As you can see, this is the first one, and this is the second one that already created my Docker sample, and this is the tag. And we are able to add tags always here using the Docker extension. Also, we click here Docker, and we can find our images here. And this is, you can create for the first one or for second one, so it depends. So I will try to use this one. Right click, and we have tag. Here we can say, for example, 2.2, for example, and have enter. This is how we create a tag using Visual Studio Code or any other. After tagging an image, now we see how we are able to how we can optimize our Docker file. Let's start by the first one, is that it's better to select the right .NET Docker images. In our case, we work .NET application, but it can be for Java, for PHP, for any other application. So it's better to go to see the official .NET Docker images that are publicly available in Microsoft repository on Docker Hub. Always we search for our image in Docker Hub. The process of identifying and picking up the right container-based image while building application can be confusing. So to simplify the selection process, most images repository provides extension tagging to help you select both a specific framework version. They also let you choose the right operating system, like a specific Linux distribution or Windows version if you use a container using Windows environments. In our case, if we go back to our application here, and I will check here before the image. If we click in any image that we already created, we see that we have some vulnerabilities. If you use command line Docker, your Docker scan, you can find these vulnerabilities because we Debian, this distribution, can include some vulnerabilities. As you can see here, we have some details about this distribution. And in this case, better to use Alpine, for example. And it's simple to do that. Just we will add Alpine in our case here, and Alpine in our case here. It's the Linux distribution that we are able to use it. We are trying to build and to see if we have the same vulnerabilities or not. This is the first best practices that we are able to use. So I will try to create the third one here. So here the third one. So we built a third image, another image just to see the difference between the first or second image, because we use the same Docker file, and the this one that include Alpine environments distribution of Linux, new distribution of Linux. So it takes few seconds here. And here, let's check before in image. We can see here that the size here, we will see the difference between the size using Alpine and using another distribution of Linux or Windows version. If you prefer using Windows environment in your containers, it depends from the needs, from your solution, from the environment. It can be a legacy application, so we need to use always, in this case, Windows environment. And you can see here the tag. This is the tag we use. Tag with here as distribution. It's like a Git commit, so we need to have a different tags for every Docker files to see the difference between the different images. And here the size is different. And if the best practice to minimize the attack is having a small size always. You minimize the surface attack. In this case, it's better to have a small size, and this is why we use container always. So to have a small image, small container, so we are able to manage easier than a big environment based on virtual machines. So this is first one. We try to run always. If you want, we use run using this one. I will leave this one, so we can use this solution. So we set this one image. We use the third image to run our solution. And here, if we go back, we see that it's in use. And this is, we always have a running on the same port. This is our application running using this image. This is our container that include our application where we are able to run it. So go back to our second best practice in our case here is to optimize the Docker file for .NET Restore. When you build .NET application with Docker, it's important to consider how Docker catches layers while building your application. A common way to leverage to build cache is to copy only the .NET, the .cs proj, .sln, and NuGet config files for your app before performing a .NET restore, instead of copying the full source code. So the NuGet package restore can be one of the slowest part of the build, and it only depends on these files. By copying them, the first Docker can catch the restore result. For example, you don't need to run it again for only change a .cs file. In our case, we will try just to optimize our Docker file using just Alpine. I will show you here how we can update this one. Just in .restore, I just minimize here. In .NET Restore, we will use this one. This is the difference between it, and use this arguments here with true publish ready to run. And here we are able to build and create always another, for example, another tag. We use another tag to see the difference between the different images. So it takes few times to be done, but it's one of the best practices to add Alpine. This is the environment that we are able to use it. It's for Linux distribution in .NET Restore. Maybe it takes few times. We can go back after, and let's check the another best practices in our case, that is using a multi-stage build. With multi-stage builds, Docker can use one base image for compilation, packaging, and unit tests. Another image, then hold the application runtime. This makes the final image more secure and smaller in size. Multi-stage Docker builds are a great way to ensure your build are reproducible and as lean as possible. You can create multiple stages within a Docker file and control how you build your image. The .NET SDK includes the .NET runtime and tooling to develop build and package .NET application. One best practice while creating a Docker image is keeping the image compact. You can containerize your .NET application using a multi-layer approach. Each layer may contain different parts of the application like dependencies, source code, resources, and even snapshot dependency. Alternatively, you can build any application as a separate image from the final image that contains the runnable application. To better understand this, let's check our Docker file created previously. Here we can see that it's already done. Let's go back just to the image to see the difference between this one here. So this is we add best practice. We have the same size in this case, and in our Docker file we already use two stage. The first one is the build stage, the runtime stage, and according to your application you can use multiple stage. So we recommend to see how you can use multi-stage in your application. And another best practice here is to run as a non-root user for security purpose. While running an application within Docker container, it has default access to the root for Linux or administrator privilege for Windows. This can undetermined application security, so you can solve this problem by adding user instruction within your Docker file. So the user instruction set the preferred username or UID and optionally the user group or GID while running the image and for any subsequent run CMD or endpoint instruction. So let's go back to our Docker file and we will add our we will add here this one we will add this command line to create this instruction. Let's say to create our user. I will just copy here and here we have the no user root no root user. So this is we run add group here and add here we have this is one and add group and here we have the user app user. So we use this command line, so it's simple, and we can just build this one to create another one, for example. This is really simple to do that, and we can run our solution using this best practices. So it can take few seconds. Let's go back to our next best practice is to use using docker ignore to increase the build performance. It's really one of the best practices that we recommend is to create a .docker ignore file in the same directory as your Docker file. With a .docker ignore file, you can identify which components are vital. So they will ultimately belong to the new image that we are building. For example, if you don't want to include the bin and the conf directory in your image build, we just needed to indicate that within our .docker ignore file. So here, if we go back to our application here, we can just go back, click here, docker ignore here. Simple, it's the same way, in the same, we need to add it in the same directory of your solution. Or we can just generate it, for example, here, as we said we did before. We show you because before it doesn't work. Here we add Docker file and we select this one, for example, here. I will always use my Docker file, but I will show you how you can create automatically the .docker file if you are not sure what you need to include in this Docker ignore. I don't know what happens when I try to listen, but it's simple here. We try to check that after. So, okay, here it requests me. No, I don't want to override this one. Okay, but just simple here. You can see here the .NET Docker ignore are added. I left the same Docker file in our case. Here we have Docker ignore that include the different things that we don't want to include them in our when we run and build our image. Another best practice is to add health check to your containers. It's really important to do that. We use health check instruction to say Docker how to test a container and confirm that it's still working. This can detect, I give an example, when a web server is stuck in an infinite loop. For example, we have some issue with the web server or unable to handle new connections, even though the server process is still running. When an application is deployed in production, an orchestrator like Kubernetes or Service Fabric will most likely manage it. By providing the health check, you are sharing the status of your containers with the orchestrator to permit management tasks based on your configuration. So when we add the health check in our Docker file, we can see the container's health in the status column while running docker ps, and the container that passes this check display as healthy and is unhealthy display unhealthy. It's really simple to add. Also, we go back here, I will close this one, and in our docker file we will add this health check. I will just copy this link. So it's really simple. We add it here in the end before the endpoint and the expose here. So here we have health check. We have multiple let's say parameter that we able, or arguments, let's say arguments that we are able to use. You can check that in the documentation of Docker. And here we have the link where we check the health. As you can see, we use this command line to add the health check. And you can use docker ps to see the health, to see the healthcare, let's say, if it's you have a problem in your container or not, in this case. So this is another command block that we added as a best practices. Let's go to another best practice, that's to optimize your startup performance, so you are able to improve .NET application as startup times and reduce latency by compiling your assembly with ready to run compilation. However, this will increase your build time. As a compromise, you can do it by setting publish ready to run property. We already use it for our case in the .NET restore, if you remember how in the restore. And now we will use multiple parameters in .NET publish for application. Let's go back here to our Docker file and made some optimization, and our Docker file will have this view. For this one, I will just copy, and this we added all this one. So no restore, and we have already Alpine, and here we have the publish, and here we added publish treatment true, publish ready to run. We will use publish single file, and we have self-contained true also here. We add all this command line. If we try to, let's say, to build another version here, in another version of our image, another image using another tag, this can take few seconds, not few seconds, maybe it takes more time than more time to build our image. So let's leave it building, and we try to see another best practices here. This is applied only for Windows container. We need to choose the appropriate isolation mode for Windows container. We have two modes for runtime isolation for Windows container. The first one is process isolation or the Hyper-V isolation. What is the difference between them? So for the first one, process isolation, we have multiple instances are running concurrently in the same host with isolation of the file system, registry, network port, process, thread ID space, and object manager namespace. It's almost identical to how Linux run containers run, let's say. The second one, that is Hyper-V isolation, the containers run inside a highly optimized virtual machine which provides hardware level isolation between containers and hosts. And most developers prefer the first one, that is process isolation. When developing locally, it typically consumes few hardware resources than Hyper-V isolation. Other developer must account for the additional hardware needed while running the container in Hyper-V mode. So here it's really simple. Uh, you can specify the isolation level by adding in your run. When you try to run your container, you need just to specify isolation process, and you give this one the environment that you like to run your solution. This is the isolation processes, and this is what you need to add when you run your image, your image as a container. This is another best practices. Let's go back maybe to our. It's still running. Takes few minutes. I would like just to see our final Docker file. Let's say, and just to check here the different tips to containerize your application. You need to select the right .NET Docker images. We optimize the .NET restore your Docker file. It's always about the Docker file. I recommend to use multi-stage build. Always don't specify latest. I know that sometimes you'd like just to use latest to get always the latest version of your .NET framework, like 7, and recently we have 8 in preview mode. But I recommend to use always the version 7, 6, 8, whatever. And we need to run as no root user for security purpose. Use always .docker ignore file. So it's simple. I don't want to run our images using the object bin, for example, whatever. So it depends from your solution. Add the health check to your container. It's really important to have an idea about what happens to my container. At least I have an idea if it works. It's not working. Why it's not working? So it's simplify. It will simplify for a developer to check if we have a problem or not. And we optimize the startup performance. We can add multiple, as we said before, multiple arguments to .NET publish. We can add more instruction always to optimize startup performance. And if you are working with Windows container, select the appropriate isolation. I'll try to go back here. I think we have some issue here. Okay, I need to make some changes here. I will try to check again. But meanwhile, if you have any questions, let's try to check the chat. Maybe I will try to again to build again. So here we have the first stage. Here we have the publish with the different parameters. We added multiple parameters. And as you can see here, we made some change according to the runtime. Here, it's better to use this runtime as best practices in Alpine always instead of ASP.NET. Here, one of optimization that added environment ASP core URL, and it optimized the startup performance here. It's really simple. If you are using after environment production, you can have multiple environment here. I specify I drag just to have an environment based on this port. And here we have the root user, we have the health check, and thank you for joining me today. We'll try to check the chat before going to see. Do we have any questions here? And if you'd like to learn more about container, about moving to the cloud, also I have already 2 books in by Pack Edition. That's I think it's one of the sponsor of this event. So you can reach me if you'd like an idea. No question, I think. Okay, no questions. Try just to check. It takes time, sorry, but we will see that we will have an optimized time, the size also with this Docker file. In my GitHub, I will try maybe to add a link about my GitHub. You can find all these best practices in GitHub. I will share also the presentation, so you can reach me if you have, and maybe I will share that on social media or I don't know how we can do that, but you can follow me to have the presentation, to share this presentation and all this demo. Thank you. No questions, guess. Thank you. Have a nice day.
Bye.